A supermassive black hole is not just existing at the center of its galaxy, but actively killing it by cutting off its star-forming fuel. This astonishing event is happening 11.5 billion light-years away in a galaxy known as Pablo's galaxy. For the first time, James Webb Space Telescope has captured this violent cosmic process in action, adding light on how black holes can shape the fate of their galaxies. In this video, we'll uncover what's happening in this distant galaxy, why it's so important, and what it reveals about the powerful influence of black holes in our universe. Now, what do we mean by starvation? In the cosmic sense, galaxies need a constant supply of cool, dense gas to form new stars and continue their growth. If this supply is cut off, galaxies enter a quiescent state, effectively halting star formation. This evidence confirms what scientists have long suspected, that supermassive black holes can actively quench their host galaxies by removing star-forming material. This incredible sensitivity allowed it to detect a dense, cooler component of these gas winds, something that previous telescopes have missed. This denser gas is crucial because it blocks light from galaxies behind it, acting like a cosmic curtain and giving us a more detailed view of the black hole's destructive power. But why is this discovery so important? For decades, astronomers have theorized that supermassive black holes play a critical role in regulating star formation in their host galaxies. However, until now, we lacked concrete observational evidence to support these theories. Webb's observations of Pablo's galaxy provide the first solid detection of a black hole killing its galaxy by cutting off the gas supply. This discovery is a significant step forward in our understanding of galaxy evolution and the role that black holes play in it. Furthermore, the discovery challenges our assumptions about the nature of early galaxies. Most galaxies in the early universe are bustling with star formation, churning out new stars at a rapid pace. Yet here we have Pablo's galaxy, which, despite its massive size, which is 200 billion times the mass of our Sun, has been rendered dead at a time when most galaxies are teeming with activity. The James Webb Space Telescope's observations of Pablo's galaxy provide a vivid example of a phenomenon known as feedback. In astronomy, feedback occurs when the intense energy released by a black hole as it pulls in surrounding material, such as gas and dust, pushes that material outwards. This ejected gas is crucial for star formation, and when a black hole expels it, the galaxy experiences quenching, effectively stopping the formation of new stars. What makes this observation special is the unexpected aspect of this quenching process. One might assume that such violent ejections of gas would create chaos within the galaxy, causing its stars to become disorganized and potentially altering the galaxy's overall structure. However, in Pablo's galaxy, the stars continue to move in a well-ordered fashion, suggesting that quenching does not necessarily lead to structural breakdown. This finding challenges previous theoretical models that predicted a more chaotic outcome, providing new insights into the complex interactions between galaxies and their central black holes. This discovery also prompts a re-evaluation of what defines a dead galaxy. Traditionally, astronomers have classified a galaxy as dead or quiescent when it no longer forms new stars. However, the case of Pablo's galaxy shows that star formation can cease even when a galaxy retains its mass and orderly structure. This raises new questions about the criteria for defining a dead galaxy, and suggests that there may be more to a galaxy's life cycle than previously thought. These findings open up fascinating avenues for understanding the early universe. They prompt us to ask how and why some galaxies manage to grow to such massive sizes, only to have their star formation abruptly halted by their central black holes. The research team plans to use the Atacama Large Millimeter, Submillimeter Array, and Chile to further investigate Pablo's galaxy. The possibility to detect cold gas and dust will help determine if any cool, dense gas remains and how the supermassive black hole's activity affects its surroundings. These observations aim to provide deeper insights into the interactions between black holes and their host galaxies, and how these relationships evolve over time. But Pablo's galaxy isn't the only known example of a black hole killing its galaxy. There are other instances where similar processes have been observed, reinforcing the idea that black holes can be both creators and destroyers in the cosmic theater. One such case is the galaxy MAX 2129-1, observed by the Hubble Space Telescope. This galaxy, much like Pablo's galaxy, was found to have a quenched state caused by its central black hole. Another example is the galaxy cluster MS, where the supermassive black hole at the cluster center released massive amounts of energy, heating the surrounding gas and preventing it from cooling to form new stars. These examples, alongside Pablo's galaxy, suggest that the quenching of galaxies by their central black holes might be a common phenomenon, especially in the early universe. The question then becomes, how frequently does this happen and what triggers it? By comparing these instances, astronomers hope to identify patterns that could lead to a better understanding of the environmental and internal conditions that make galaxies vulnerable to such dramatic transformations. What makes these findings so special is the direct evidence they provide for a process that was long theorized but never clearly observed. Webb, with its unprecedented sensitivity and resolution, allows us to see the universe in ways we could only imagine before. By capturing these detailed views of distant galaxies, Webb is not only confirming existing theories, but also challenging and refining them. Thank you for joining us today. Don't forget to like, share, and subscribe for more exciting updates.